All right, let's talk about a word that I know can sound a little intimidating, thermodynamics. But I'm going to make you a promise. If you stick with me for the next few minutes, you'll see it's not some complicated thing for scientists. Nope, it's actually the rulebook for your entire life. Let's jump in. So, be honest. When you see this word, thermodynamics, what pops into your head? Probably a bunch of complex equations, maybe a thick, dusty textbook, right? Yeah, for a lot of us, it just feels totally abstract, like something that only happens in a lab somewhere. But here's the thing. It's not abstract at all. Thermodynamics is happening all around you, right now. It's the story of why your hot coffee eventually gets cold. It's why an ice cube melts in your glass. And it's why your phone gets warm when you charge it. Simply put, it's the fundamental set of rules for how energy works in our universe. Okay, let's start with a law that's so important they actually had to go back and add it in after they'd already named the first, second, and third laws. We're going to call this one the equalizer, but scientists call it the zeroth law. Now, I know what you're thinking. That sounds almost too simple, right? But this is the bedrock for everything else. Here's all it says. If thing A is the same temperature as thing C, and thing B is also the same temperature as thing C, well then A and B have to be the same temperature as each other. And you know what? This simple little rule is the entire reason a thermometer can even work. Think about it. When you stick a thermometer in your mouth, you're not getting an instant snapshot. What's really happening is you're waiting for your body and the thermometer to reach a state of balance, what's called thermal equilibrium. Once they're at the exact same temperature, then, and only then, can the thermometer actually show you an accurate reading of your body's temperature. That's the equalizer law, right there in action. All right, now that we've got our foundation, let's move on to the first law. I like to call this one the energy accountant because really, it's all about keeping the universe's energy books perfectly balanced. You've probably heard this one before. It's one of the most famous principles in all of science. You can't just make energy out of thin air, and you can't make it disappear. The total amount of energy in the universe is always the same. It just changes forms. It might go from chemical energy in a battery to electrical energy powering your phone to the heat you can feel coming off of it. So the math behind it is actually just like simple accounting. The change in any system's energy is just the energy you put in minus the energy that goes out. Think of it like your bank account, right? The change in your balance is just your deposits minus your withdrawals. You're not creating money out of nowhere, you're just moving it around. Let's go back to your phone. This is a perfect example. When you plug it in, electrical energy flows in from the wall charger. Some of that energy is lost as heat, flowing out. That's why the phone and the charger get warm. And whatever is left over gets stored as chemical energy inside the battery. See, no energy was created or destroyed. It was all just moved around and perfectly accounted for. Okay, now we get to what is honestly my favorite one, the second law. This one explains so much about why the world works the way it does. We're going to call this one the messy room law. The big, important word here is entropy. And really, that's just a fancy scientific word for disorder, or randomness, or just plain messiness. And what the second law says is absolutely huge. In any closed system, like our universe, the total amount of messiness will always go up over time. It's like the universe just naturally prefers a state of chaos. Just look at these examples, it'll make perfect sense. A brand new deck of cards, all sorted by suit and number, that's low entropy. It's very ordered. But the second you shuffle it, you've introduced disorder and increased the entropy. Or think about your bedroom. It doesn't magically clean itself, does it? No. It naturally trends toward being messy. And an ice cube, its water molecules are locked in a perfect ordered crystal. But when it melts into a puddle, those molecules are all jumbled and moving around randomly. In every single one of these cases, nature is moving from order to disorder. And this is the deep reason why your coffee gets cold. All that concentrated heat in your small mug is a very ordered state of energy. The universe doesn't like that. It prefers to spread that energy out to make it more disordered, more random. So the heat naturally flows out of the hot cup and into the much larger, cooler room, increasing the total entropy of everything. It never goes the other way. In fact, this constant march towards messiness is what gives time itself a direction. It's why the mess always wins. So if the universe is always getting messier, is there any hope for order? Is there an opposite to this chaos? Well, that brings us to our final law, the third law. Let's call this one the big freeze. So this final law makes a very clear connection between temperature and that idea of entropy or messiness. The simplest way to think about temperature is that it's just a measure of how much molecules are moving around. When something is hot, its molecules are vibrating and zipping around like crazy. As you cool it down, they start to slow down. The third law basically asks, what happens if you take that to the absolute limit? Well, at the coldest possible temperature, a point we call absolute zero, all of that molecular motion would just stop. That temperature is 0 on the Kelvin scale, or negative 273.15 degrees Celsius. At that point, you'd have a state of perfect absolute order. Entropy would be at its absolute minimum. So here's the key idea. While the universe is always trending towards more chaos, the concept of perfect order does exist, but only at this impossibly cold theoretical point. And the craziest part? It's a finish line we can get unbelievably close to in labs, but can never, ever actually reach.
Phew. Okay, that was a pretty quick tour of the universe's entire operating system. So let's do a fast recap to put it all together and make sure it all sticks.
So let's lock this in. The zeroth law is the equalizer. It's why we can trust a thermometer. The first law is the energy accountant. It reminds us that energy is never created or destroyed, it just changes its costume. The second law, that's the messy room, the unstoppable fact that things in the universe naturally fall into disorder. And finally, the third law, the big freeze, which tells us that perfect order is possible, but only at the coldest temperature imaginable, absolute zero. So you see, these aren't just some abstract rules in a physics book. They are the invisible forces that govern everything, from the engine in your car, to the phone in your hand, to that cup of coffee sitting on your desk. So the real question is, now that you know the rules, where are you going to see them at work next? Thanks for watching.